So let's scroll down to the first part, that is the MCQs, and I'll try to fast forward these ones. What is the direction of the resultant force? So we are provided with three forces. Let's say this is the first one, this is the second, this is the third. The rule says pick up the second one, place it at the end of the first. So I pick up this one, place it at the end of the first. Then pick up the third one and place it at the end of the second. So this one, which is 1 2 3 blocks, 1 2 3 blocks. So the third one picked up from here, placed it at the end of the second one, and now the final answer is from the start point. This is our start point, from start point to the end point. So this is the direction of the resultant from start towards the end, which is this way. So for this one, D is the right answer. Also, there are some other ways you can solve the question. You can solve 3 and 4 Newton first. You can get the answer of these two, and then you can combine it with this third one. What correctly expresses the volt in terms of the base units? So volts is written as W over work done per unit charge. For the work done, the SI base units are kg m2 s minus 2. For charge, we have as. So what do we get is kg m2 s1 goes upstairs would be -1, so s minus 3 and a minus 1. We have D as the right answer for this. Let's move on to the next one. Two forces are given, the angle between these two are given. What is the magnitude of the resultant force? Plenty of ways you can solve this one. One of them is, let's say this is the first vector, this is the second vector. The rule says pick up the second vector and place it at the end of the first one. Okay, we have done this one. So if I could extend the same one, this angle, the given angle is 120. So the angle on the inside would be 60 degrees. Now what is the final step? From the start point towards the end point, draw the resultant vector. And this one was also 10 Newton. So you can use simple mathematical concepts as well, or there are plenty of ways. You can use the cosine rule, that could be used, which would be a squared plus b squared minus 2 a b cos of the angle between them. You can find the resultant one. So c square equals to this one. Then you can, whatever the answer is, you can take square root of it. Or the other way is, if these two sides are equal, the opposite angles, the angles related to these sides would also be equal. So out of 180, because triangle could be only 180, 60 is here, and the other two have to be equal. So the only possible way is if these two are also 60. What kind of triangle do we have? Equilateral triangle. If all three angles are equal, then all three sides should also be equal. So if this one is 10, this one is 10, then the third side should also be 10. Same question can be solved by the method of components also. But this is the easiest way or the fastest way to solve it. Let's move on to the next one. Which statement about the vector and scalar quantities is correct? A scalar quantities has magnitude but not direction. Over to the next one. What is the percentage uncertainty in y? That equals to percentage uncertainty of p, 6, plus that of x, 2, plus whatever the uncertainty of q is, 2 times of it, because q is raised to the power 2. So you get 16. When must an object be in equilibrium? When there is no resultant force and no resultant moment of force. If you pick up the last one, for example, when the upward force on the object is equal to the equal and opposite to its weight? May not necessarily be a case. But what about the horizontal forces then? So if you pick up the last one, what about the horizontal forces? Shouldn't those forces be equal as well? So let's talk about the seventh one. What is not possible magnitude of the resultant force? So you see, let's see what is the minimum answer that we can have from these ones. The maximum, first of all, that we can have from these is 6 plus 7, 13 Newton. 13 Newton is possible. And now, what is the minimum possible answer? The minimum possible answer could be in this case. So let's say 7 Newton here, 4 Newton here, 2 Newton here. So the minimum possible answer is 1 Newton. Anything 1 Newton is not possible. Anything below 1 Newton is not possible. So let's move on to the next one. Which statement describes the two forces in a couple? So the forces in the couple are equal and opposite. So for example, the two forces look something like this. Now what is the resultant of these two forces? Well, if this one is 10 Newton downward, then the other has to be 10 Newton upward. Only then they can form a couple. Now what is the resultant force? 0, because these two would cancel out each other. So C is the right answer. So if someone picks D as the right answer, they produce zero resultant moment. If the couple produces zero resultant moment, then how would they rotate an object? How would the steering of the vehicle steer in any direction? So let's say this one force goes anti-clockwise, but the second one also goes anti-clockwise. So there is no clockwise moment to cancel out anti-clockwise. Let's take a look at the next one. So the pivot is given as 60 mark. Just the instant when the rule is horizontal, just the instant. What is the resultant moment about the pivot? So it's a uniform beam, weight would be exactly in the middle at 50 mark, and that is 2 Newton. So 2 times the perpendicular distance from the pivot would be 10, equals to 4 times the perpendicular distance from the pivot would be 40. This one would be 40. So what is the resultant moment? Okay, so 20 here. And these two are not equal because we do have a resultant moment. So this one was what do we call this, anti-clockwise, and this one was clockwise. So anti-clockwise is this much, clockwise is this much. How much is anti-clockwise? 20 Newton centimeter. How much is clockwise? 160 Newton centimeter. So what is the resultant? The resultant of these two would be 160 minus 20, which is 140 Newton centimeter. But since all the options are given in Newton meters, I can divide this one by 100. So I'll be having 1.4 Newton meter, which is B as the right answer. Okay, then we have to find the value of n. So let me rewrite the equation. K is a constant with no units. I can ignore this one and raise to the power n. P is the power. The units, SI base units of power are kg. Basically work done over time. But I always tell the students to memorize the units of pressure, power, energy, and force. Pressure, power, energy, and force. Energy or work done is the same thing. So this is for the power, equals to density is kg m minus 3, area is meter square, speed is ms minus 1, but this thing is raised to the power n. So if we could do some cancellation, we can. So for example, kilogram from here cancelled away with kilograms from here. What else do we have? Nothing else can be cancelled out. So what are we left with on the left side? m2s minus 3, and on the right side we'll be left with m minus 3 shifted here, m2 also shifted here, and only this thing remains on the right side. Now let me do some cancellation on the left side as well. So m2 cancelled away with m2. What are you left with? You're left with m minus 3 downstairs. If you take it upstairs, it would be m3. Alongside m3, you have s minus 3, s raised to the power minus 3, and ms minus 1 raised to the power n. Now the left side can also be written this way. So instead of saying m3 s raised to the power minus 3, you can say ms minus 1 raised to the power 3. Right side as it is. Now you see the two bases are same. ms minus 1 on the left side, ms minus 1 on the right side. If the two bases are same, you can compare the exponents. So we can say n equals to 3. Let's move on to the next one. The name of the suitable measuring instrument. So you see the measurement goes to 2 decimal places in millimeters. So the suitable instrument from our syllabus could be micrometer, screw gauge. Micrometer, screw gauge. So let's take a look at the next one. So D is the diameter. How random errors may be reduced when using the instrument in number 1. And the question is for 2 marks. So take several readings and find the average. That will lead to only 1 mark, because the question for 2 marks, so you got to be very specific. So if this is a wire, and what if you keep taking several readings at the same place? That won't make any difference. Probably all the readings would be same. So the better way is, first you can take a reading at the start of the wire, starting point of the wire, second reading someplace in the middle, third reading someplace close to the other end, fourth reading someplace at the other extreme end. So you take several readings along different parts of the wire. That would give you 2 marks. Take several readings along the length of the wire, means along different parts of the wire, and take average. The other method, which I see many of the students write for this one, is to avoid the parallax error. So you write for the parallax error only if the scale is vertical and the scale was not difficult to read. But that's not the case here. You have the micrometer, you can bring the micrometer right in front of you. So when the scale is vertical, you have a stand here and the scale is placed like this. In that case, there is a chance of parallax error. But for a horizontal thing and for the instrument which can move very easily, the parallax error, the chances are slim to none. Anyway, let's move on to the next one. Show that the value of sigma, which is the stress, is this much, and it has to be in Newton per meter square. What does that mean? The diameter has to be converted into meters. Only one conversion was there, 0.40, sorry, 0.4 into 10 raised power minus 3 meters. So let's move on to this one. 4, the value of f would be 25 divided by pi as it is on the calculator, and the value of d would be 0.4 into 10 power minus 3, and square of it. You hit it on the calculator as it is. The answer to this one would be 1.99 into 10 power 8. Determine the percentage uncertainty in sigma. So for the percentage uncertainty, we're going to ignore the constant numbers. If I ignore the constant numbers which have no units, so I'll be left with f and d square. So I'll need to find the percentage uncertainty in f. I'll need to find twice of the percentage uncertainty in d, and I'll simply need to add them. So what is the percentage in f? Okay, let's find it. 0.5 divided by 25 times 100. That is the percentage in f. So 0.5 divided by 25, whatever the answer is, times 100, 2%. What about the diameter? When you're finding the percentage uncertainty, no need to convert millimeters into meters. If you convert, then you have to convert both of them. The ratio would be same, so you can find directly. 0.02 divided by 0.40, whatever the answer is, times 100, 5. The percentage uncertainty in diameter is 5. But since it was square of the diameter, so 5 would be 2 times of 5%. But for force, it would be used as it is, 2%. So the overall answer would be 12%. You can write it in 1SF also, or in 2SF as well. So 10 or 12, both are acceptable. Therefore, the last one, use the information and your answer to determine the value of sigma with its absolute uncertainty to appropriate number of significant figures. So the value of sigma was 1.99, if I could recall, into 10 to the power 8 Newton per meter square. The uncertainty, percentage uncertainty in sigma was 12%. We need to find the absolute uncertainty. So I'll simply find 12% of the principal value. This is your principal value. So 1.99 into 10 raised power 8. I gotta find 12% of it. So let's see what do we have. Hit the fraction, 1.99 into 10 raised power 8. Whatever the answer is, times 12. Whatever the answer is, times divided by 100. So what I get is 2.3 into 10 raised power 6. 2.388. Sorry, if I write 2.3, it would be 2.3 into 10 raised power 7. Because 23.2 10 raised power 6 can also be written as 2.3 into 10 raised power 7. The other way is you press shift mod go to the scientific form, you can write in 2SF. We get 2.4 into 10 to the power 7. So this is the absolute uncertainty. 2.4 into 10 to the power 7. This is the absolute uncertainty. But there's more to it, because we got to write the answer to appropriate number of significant figures. Now, there are two things you need to consider here. First of all, the absolute uncertainty has to be to 1 SF. So you got to round off this one to 1 SF. In 1 SF, it would be 2 into 10 to the power 7. So what is our final answer? 1.99 into 10 to the power 10 raised to the power 8 plus minus 2 into 10 to the power 7. But now you have to make sure the exponents are also same. Whenever you write uncertainty with the principal value, the two exponents should be same. So the second one, you can write this one 0.99 plus minus, into 10 to the power 8 plus minus 0.2 into 10 to the power 8. 2 into 10 to the power 7 and 0.2 into 10 to the power 7 are the same things. Now, the last step. After you converted the absolute uncertainty to 1 SF, how many decimal places you have? In this case, you have only one decimal place. Now, the principal value should also be to 1 decimal place. You need to round off the principal value to ensure that you have same DPs for the uncertainty and for the principal value. So this could be written as 2.0 into 10 to the power 8 plus minus 0.2 into 10 to the power 8. Don't forget to write the exponent with the second one as well. Or if you don't want to write it for the second one, you want to write it only once. So in that case, you can write it this way. 2.0 plus minus 0.2 in all of it into 10 raised to the power 8. This is the other way you can write the answer to this one. Okay, up next we have a definition. For an object to be in equilibrium, the sum of clockwise moments equal the sum of anti-clockwise moments about a point, or about a fixed point, or about any point. But whatever point you choose initially, then you find all the moments across the same point. So about a point has to be added in the definition. Let's consider the next one. By taking moments about end A, show that the weight W of each wheel is 14. Okay, so we need to find weight of each wheel. We need to find the value of W. So what is the pivot? This is a pivot. A is a pivot. So this one goes clockwise, CW clockwise, CW clockwise, ACW. Only the last one is anti-clockwise. So let's do it this way. Clockwise on one side, all the clockwise moments on one side, all the anti-clockwise moments on the other side. So what do we have clockwise? The first one is W times 0.45. Done with the first. The next one is 19, and the perpendicular distance from the pivot would be so 19 is the weight of the beam, and since it's a uniform beam, so weight would be exactly in the middle. So the total length is, if you could add all of them, you get the total length 0.45 plus 1.4 plus 0.75. Whatever the answer is, divided by 2. change the mode also. So we get 1.3 times 1.3 plus W again, but this time W times this much, 1.85 equals 22 times the total length, which is 2.6. It's all mathematics from here. I just need to rearrange, need to find the value of W. What you can do is find the answer of this one, take this thing on the other side and subtract from this one. And these two would be the like terms, these two would be combined, and the coefficient of W would be divided. So the answer should be 14. Determine the magnitude of and the direction of the resultant force acting on the rod at end A. So in order to solve that kind of question, we use the principles of equilibrium, the conditions of equilibrium. Sum of the forces downward should equal to the sum of the forces upward. So what are the forces downward? Now weight has to be found out already. That should be 14. So W should be 14, weight of one of the wheels should be 14. Now what is the total downward force? Well, Alright, so for this one, we use the principle of equilibrium. The sum of the vertical forces should be equal. The net vertical force should be 0. So what is the sum of downward forces? 14 plus 14 plus 19. This is the sum of the downward forces. So 14 plus 14, 28 plus 19, 47. So the total force that is downward is 47. What is the total force that is upward? Right now it's only 22. But if the system is in equilibrium, there should be another force that should be vertically upward. So that force is there at the pivot A, through the pivot A. How much is that? You can subtract these two, because there has to be a force that needs to be added in 22, so that the upward force should also be 47. Only then the system can be in equilibrium. So what do you do is 47 minus 22, which is 25, which is 25. So there has to be a force of 25 Newton upwards. So 25 Newton and upward. How do we know upward? Because initially the downward force was greater, so the force has to be upward. Only then upward force, total upward force would equal total downward force. Let's move on to the next one. So here we have the situation. The first part is draw an arrow to show the approximate direction of the resultant of these two forces. If this is the first vector and this is the second vector, now we gotta follow the rules. The vector triangle method or head tail method says pick up the second vector and place it at the end of the first one. So you pick up the second vector and place it exactly at the end of the first one. So something like this. And how much is that? 2.5. Now, what is the last part? In the end, you join the start point. You join the start point to the end point. That is your resultant vector. And if you could form the angles, you see, if I could extend this line over here, and then I could see this angle is 30, because these two would be vertically opposite angle. This one is 30, this one would also be 30, and then the angle on the inside would be 90 minus 30, which is 60. Now, so this is a vector triangle method. If you draw the resultant vector like this, you get the first mark. Show that the magnitude of the resultant vector is 6.6. So you can use the cosine rule. You're provided with two sides and the included angle. So the cosine rule would be a square plus b square minus 2 b cos of the angle between these two. Whatever the answer is, take square root of it. In 2SF, you'll be getting 6.6. All right, or you can use the scale drawing method. The scale drawing method is there, and matter of fact, there's a method of using the components. Any of the method could be used. And how do you solve from here? Well, you write it all together all at once. Plus 2.5 square minus 2a, and b would be this much, and cos of the angle between these two was 60, and square root of the answer 6.614. In 2SF, we get 6.6. Let's move on to the next one. Determine the angle between the direction of the acceleration. Direction of the acceleration is the same as the direction of the resultant force, because we carry forward this formula from O levels or IGCSE, that resultant force is proportional to acceleration. And their direction is same, even in the circle. So we need to find the angle between the resultant force and the 7.5 Newton force. So which one is the resultant? This one. 7.5 is this one. What is the angle between these two? This one. So you can use the sine rule. Let's call this one A. The angle opposite to this one would be capital A. It needs to be found out. This one you can call B. The angle opposite to this one would be capital B. So let us use the rule now. A, or sine A over A, equals sine B over B. What is sine A? Sine A would be sine of angle theta, which needs to be found out. Side A is 2.5, equals to sine B would be sine 60, divided by side B would be 6.6. So sine theta equals to sine 60 divided by 6.6, and 2.5 would be shifted on the other side. So fraction sine 60, bracket closed, 6.6 in the denominator, times 2.5. Whatever the answer is, you take sine inverse of the answer, you get 19.14. In 2SF would be 19. Let's move on to the next one. Energy is scalar, momentum is vector, power is scalar, time is scalar, weight is vector. Sketch a vector diagram to show the path taken by the girl. Draw and label her resultant displacement r. So you have to sketch the vector diagram. You don't have to scale it, and since the question is also for 1 mark only, so the first vector is 120 meter towards north. So this could be the first one, 120 meter towards north, and the second one is 80 meters towards east. So this could be the second one, 80 meter towards east. So first one, since it is just sketching, question is only for 1 mark, you can draw it without the scale. You don't have to scale the diagram. What is the last step? To show the resultant vector, you join the start point to the end point. And you don't have the colored pencils for the paper, so you can draw the resultant with double arrows. Okay, then we have the next one. Calculate the percentage uncertainty in t. So that would be 0.03, second value, divided by the first value, times 100. You get it as 1.6. The second one in length would be 1 divided by 92 times 100. And this one you would be getting 1.1. Okay, then you need to find the percentage uncertainty in the value of g. So I'm going to ignore all the constant numbers. They have no use for the percentage uncertainty. So percentage uncertainty in g would be equal to the percentage of L plus twice the percentage uncertainty of time. Why twice? Because it's t raised to the power 2. Now what is the percentage for length? Well, that was 1.1 plus 2 times of 1.6. So 2 times of 1.6, 3.2 plus 1.1 would be 4.3. So 4.3 is the answer. The value of L and T are used to calculate the value of G as this one. By reference to the measurements of L and T, suggest why it would not be correct to quote the value of G as 9.751 meter per second square. Let's take a look at the raw data. The first raw data is in 3SF, the second raw data is in 2SF. The general rule is the final answer should be in least number of significant figure, or you can add one more. So the maximum number of SF that should be there in the value of G should be 3. You cannot go more than that, because you cannot have the number of significant figures more than the raw data. So the least in the raw data was 2. Either you can have in 2SF, the final answer in 2SF, or you can add just one more. But you always consider the least SF as a checkpoint. So same as least SF or add one more. So the final answer could be 2 or 3 SF. But what is the given value in 1, 2, 3, 4? 4 SF not possible. So since minimum as SF in raw data are 2, or since minimum value in raw data has 2 SF, so G can only be in 2 SF or 3 SF. And also the other way of thinking about this one is that the uncertainty, if you could find the uncertainty in G, It would be 0.4, which we solve in the next part. So if the uncertainty is to one decimal place, generally the value of g should also be in one decimal place. Because there's large uncertainty, you cannot be sure about to a third decimal place. Let's move on to the next one. You need to find the value of g along with the uncertainty to appropriate number of significant figure. So the value of g, how do you find it? It should be in meter per second square. So 92 would be 0.92 meters, and g equals to, the expression is 4 pi square L divided by t. Okay, 4 pi square L would be 0.92 divided by t square, so 1.93 square of it, with the fraction 4 pi square times 0.92 divided by 1.93 square of it, 9.75. Okay, so I'm just writing the final answer at this side, 9.75. Now what is the absolute uncertainty? For the absolute uncertainty, we need the percentage uncertainty, which is 4.3. So I'll find 4.3% of my principal value. How do we find it? 9.75 times 4.3 divided by 100. So let's hit it on the calculator. Times 4.3 divided by 100. We get 0.412. Sorry, 0.419. But this one has to be to 1 SF. So in 1 SF, it would be 0.4. Now how many, after we convert it into 1 SF, how many DPs do we have? 1 DP. So the principal value should be written to 1 DP as well, 9.8. So let's move on to the last one. Define the moment of force. So moment of force is defined as the product of force and perpendicular distance from the force. Sorry, from the pivot. And if you gotta be more precise, you can say the product of force and perpendicular distance between the line of action of force and the axis of rotation. Anyway, let's move on to the next one. Determine weight of the student for 3 marks. So this is a pivot. This one would be ACW anti-clockwise. This one would be clockwise. So let's write anti-clockwise on this side. Anti-clockwise is W. What is the perpendicular distance from the pivot? 0.50 minus 0.3. 0.20 equals to 80. Since 80 is the uniform plank, the total length is 2 meters. So weight would be at 1 meter. But then the distance from the pivot would be 1 minus this one. So in order to find this distance, so 1 minus 0.5 would be 0.5 plus this another one clockwise also, 70 times this distance. We can find this one. So how do we find this one? Is the total is 2. From 2 meters you can subtract this distance 0.5, and you can subtract this distance also. So 2 minus 0.5 would be 1.5, minus 0.2 would be 1.3. This is how you can find the distance of the 70 Newton force from the pivot. Once again, what distance is this? This one. From here all the way to here. So W times 0.2, 80 times 0.5, 70 times 1.3. If you could hit it on the calculator for the value of W, the weight of the person would be 655 Newton, which is which makes sense also. And keep in your mind, it's not the mass of the person, it's not in kilograms. So 655 Newton, if you even convert it into kilograms, it would be something like 65, between 65 to 70.